Hey folks, welcome to Beyond Our Future, where we discuss space, rockets, exploration missions, and everything in between. In today's video, we'll find out why is the James Webb Telescope really special. So, let's begin.
The world's largest and most powerful space telescope.
From the new James Webb Space Telescope.
James Webb Space Telescope.
The James Webb Telescope, the largest and most powerful ever launched into space.
Now let's take a look at the very first image from this miraculous telescope.
You must first grind a mirror the size of a house in order to look back in time and see the first stars shine. If the mirror were the size of a continent, its surface would be so flat that there would be no hills or valleys higher than ankle height. The feeble light emanating from the furthest galaxies in the sky, light that left its source long ago and so portrayed the galaxies as they looked in the distant past when the universe was young, can only be collected and focused by a mirror so large and smooth. When unknowable forces conspired in the darkness and the earliest, very dim, far-off galaxies emerged, they were still in the process of birth. An exceptional mirror, however, is not nearly enough to read that early chapter in the history of the universe, to learn the nature of those first, probably enormous stars, to learn about the invisible matter whose gravity coaxed them into existence, to learn about the roles of magneticism and turbulence, and to learn how enormous black holes grew and worked their way into the centers of galaxies. The old starlight has gotten stretched after traveling to us through the expanding fabric of space for so many billions of years, which is why no one has ever witnessed the epoch of galaxy creation. The most distant stars in the sky emit ultraviolet and visible light, which on their journey here stretches to wavelengths 20 times longer and transforms into infrared radiation. The heat that emanates from our bodies, the atmosphere, and the ground beneath our feet is infrared light, the atom-jiggling light type that we refer to as heat. Unfortunately, these nearby heat sources overwhelm the meager fires of ancient stars. The telescope, with its large, flawless mirror, has to be extremely cold in order to see those stars. It needs to be sent into orbit. The problem is that any rocket fairing cannot accommodate a mirror the size of a house. Therefore, the mirror must be foldable. A mirror can only fold if it's segmented, or if it's made of a honeycomb-like arrangement of mirror segments rather than a single unbroken surface. However, the mirror segments must be almost perfectly aligned after autonomously unfolding in space for them to collectively produce crisp pictures. To get a decent focus, one needs incredibly accurate motors that can move each mirror segment by half the width of a virus in increments until they're all in the same location. It would also reveal other, arguably just as significant, aspects of the universe, such as the characteristics of Earth-sized planets orbiting other stars and the hotly contested rate at which space is expanding. This would give you access to the universe's formative chapter, roughly the period from 50 million to 500 million years after the Big Bang. But in addition to a perfect mirror that automatically unfolds and focuses after being launched into the sky, the telescope also needs another component in order to function. Even in space, the Earth, Moon, and Sun still heat the telescope excessively, preventing it from seeing the faint flicker of the universe's most distant objects. Unless the telescope is pointed in the direction of Lagrange Point 2, a location that's 4 times further from Earth than the Moon. There, the Sun, Moon, and Earth are all pointed in the same direction, allowing the telescope to block out all 3 objects simultaneously by building a sun shield the size of a tennis court. This form of shading allows the telescope to ultimately descend into a profound cold and discern the weak heat of the cosmic dawn. The single saving grace and fatal flaw of an infrared telescope is the sun shield. The sun shield must be made of lightweight cloth to unfold to sufficient dimensions without weighing down a rocket. The inevitability of using fabric makes the construction of a massive yet lightweight infrared sensing spacecraft dangerous by nature. Engineers claim that fabric is non-deterministic, making it hard to precisely regulate or anticipate its movements. The entire telescope will become space debris if the sun shield snags while it's unfolding. The telescope, which has miraculously been constructed, is being folded and prepared to be mounted on an Ariane 5 rocket. On December 22nd, the rocket is set to launch from Kourou, French Guiana, more than 30 years after the James Webb Space Telescope was initially conceived of and drawn out. The telescope is 20 times over budget and 14 years behind schedule. John Mather, The Nobel Prize-winning astronomer, who has served as the project's lead scientist for 25 years, stated, "We've worked as hard as we could to catch all of our faults and test and rehearse." He said, "We're going to set our Zillion-Dollar telescope on top of a heap of explosive stuff now, and leave the outcome up to chance." Due in large part to Webb's forebears, the construction of the JWST over the past 3 decades has matched the enormous strides we've achieved in our understanding of the universe. Stars, galaxies, and supermassive black holes were discovered by the Hubble Space Telescope to have existed far earlier in cosmic history than previously thought, and to have experienced significant alterations since then. We now know that the cosmos is shaped by dark matter and dark energy. With the help of the Kepler telescope and other instruments, we've observed that galaxies are decorated with a wide variety of planets, including billions of potentially habitable planets in only our Milky Way. The James Webb Space Telescope can answer some of the questions these discoveries have prompted. As with previous telescopes, astronomers also hope that its sightings may prompt new inquiries. "Every time we construct new machinery," Mather said, "we receive a surprise." The astronomer Natalie Batalha described the 6 months that followed the launch as 6 months of pins and needles, as the incredibly intricate telescope attempted to unfurl and concentrate in countless phases. The observatory will travel 1 million miles to Lagrange Point 2 by floating there, and for 1 month, it will change into a heavenly water lily en route, placing its enormous flower of mirror parts with gold plating above a larger silver leaf. According to Grant Tremblay, a Harvard University astronomer who sat on the telescope's time distribution committee, "It will be our own dare mighty things moment. It will do remarkable feats. We'll be writing about how this is one of the oldest galaxies, that we are watching the formation of stars at the edge of time, and that this is the tale of other Earths in the New York Times." When NASA attempted to deploy a significant observatory, the Hubble Space Telescope, it failed miserably. Seasoned astronomer Sandra Faber described it as completely terrible. Faber was a member of the team that camped out to identify the conditions at NASA's Goddard Space Flight Center in Greenbelt, Maryland. She and a colleague concluded that the primary mirror, which is the large concave mirror that bounces light to a secondary mirror, which then reflects it onto a camera lens, had not been ground down to just the appropriate concavity to concentrate the light. It was half a wavelength too thick. This aberration would have been discovered if the primary and secondary mirrors had been tested combined before launch, but it never happened due to the need to launch the long-delayed and over-budget telescope. Some NASA officials advocated scrapping the telescope, a contentious project already. Instead, Maryland Senator Barbara McCluskey succeeded in raising money for a rescue operation. Because Hubble is an optical telescope, sensitive to visible light rather than infrared light, and can obtain a clear picture from low Earth orbit, just 340 miles above the planet, rather than needing to go 1 million miles, fixing it was made feasible. In 1993, astronauts inserted a kind of contact lens when the space shuttle docked with Hubble. The scope would move. So, this was it for today, guys. Hope you enjoyed our content. Like and share the video if you did. Subscribe to Beyond Our Future for many more amazing videos. Stay tuned, as we'll be back soon with another informative video for your amusement. Till then, keep exploring.